Right, we're going to take a look at trial improvement as a method of solving an equation. So we've got here the equation x squared plus x equals 53, and we're told to solve this equation and give our answer correct to one decimal place. So for a question like this, you're going to need a calculator. So you'll be using a calculator to work out your answers. When we're doing trial improvement is done in a table, and your table will have 3 columns. So we'll rule out a basic table. Our first column is the value of x. So basically what we are thinking x might be, and that is slightly a bit of a guesswork at the start, and then we just try something and we improve on it. That's where the name comes from. So we try a number, and if it's not getting close enough, we will then improve on it. The middle column then is the value of our equation. So the value of, and we have x squared plus x. So whatever we pick for x, we're going to square it, and then we're going to add that number again onto it. And our target score is 53. So in here we put our comment. So if we are getting close to 53, we're going to write in that it's too big, too small, or if that's the correct answer. So for this equation, I'm going to start with, so I need to think, so 7 squared is 49. So if I use 49, or if I use 7 and I square that and I get 49, well, I'm going to be quite close to 53. So I'm going to put in here 7. So 7 squared plus 7, because the equation says I have to do x squared plus x, and x is 7. So I'm going to do 7 squared plus 7. And this is where you can use your calculator. So 7 squared is 49. And then I'm going to add 7 onto that, and that is an answer of 56. Now I want 53, so 56 is too big. Okay, so I want to get the two closest whole numbers. So if 56 is too big, I'm going to try 6 now. And I'm going to do 6 squared plus 6 equals. So again, you can use your calculator for this part. However, you can probably do this without your calculator. So 6 squared is 36, plus 6 is 42, which is too small. Okay, so we know it's somewhere between 6 and 7. We want to go to one decimal place. So I'm going to go with, I think about 6.8, because it is slightly closer to the 7 than it is to the 6. Because 53, well, it's only 3 away from 56. So I'm going to go 6.8. So I'm going to do 6.8 squared plus 6.8 equals. So calculator, 6.8 squared plus 6.8 equals 53. Okay, 53.04. So this is very close. It is still slightly too big. Now, you might think, well, that's as close as you're going to get, so I'll just go with 6.8. But you need to be sure. You need to have evidence to prove that 6.8 is the closest answer. So I'm going to try, because that's too big, I'm going to try 6.7, just to see what it will give me. So 6.7 squared plus 6.7 equals, so again, calculator, 6.7 squared plus 6.7. And that is 51.59. 51.59, which is too small. Now, we could try 6.75 to decide which one is actually closer, if it's 6.8 or 6.7. But in this case, it's very obvious that 6.8 is the closest answer, because it is only 0.04 away from the correct answer. So I'm going to write down that x is equal to 6.8 to one decimal place. Okay, so we have another one here to solve. We're going to try. Now, you can work through this yourself if you want. Pause the video, work through it, and then come back and see whether you're getting the same answer as me. Right, so the first thing you need to do is your 3-column table. So I'm going to draw out my table. First column is value of x. Okay. Second column is value of x squared plus 2x this time. And then we have our comment in at the end. So our target number we're trying to hit is 19. So we're going to need to start with something very small to get an answer of 19. So I'm thinking, well, 3 squared is 9. That's maybe a little bit small. So maybe start with 4, because 4 squared is 16. So I'm going to put 4 in here. I'm going to do 4 squared plus, and remember this time it's 2 of x, so it's 2 times by 4. Okay, so 4 squared is 16, and 2 fours is 8, so 16 plus 8 is 24, which is too big. Okay, so I'm going to try then 3. If 4 is too big, I need to try 3. And hopefully it will be too small, so then I'll know that it's between 3 and 4. So let's try 3. 3 squared plus 2 times 3. So 3 squared is 9. 2 times 3 is 6. And 9 plus 6 is 15. And this is too small. So I now know that it is between 3 and 4. Okay, so 19 and 15, there's a difference of 4 there. And between 19 and 24, there's a difference of 6. So it's slightly closer to the 3. I think I'm going to just try 3.4 because it's only slightly closer. So I'm going to do 3.4 squared plus 2 times 3.4. And I'll use my calculator for that. So 3.4 squared plus 2 times 3.4 equals, and it is 18.36. 18.36. Now this is too small, because I'm trying to get 19. So if 3.4 is too small, I need to try 3.5. So 3.5 squared plus 2 times 3.5. So I'll use my calculator for that. So 3.5 squared plus 2 times 3.5 equals, and that is 19.25, which is too big. Okay, so I need to decide now whether I'm going to do 3.4 or 3.5. I need to decide which is actually the closer one to 19. Now, looking at this, this is 0.25 over 19. This one here is 0.63 under. So that one there is a wee bit further away, the 3.4. So I'm going to pick 3.5. So x is equal to 3.5 to 1 decimal place. Now, if you want to prove that, you can actually try 3.45. That's the number between those two. So if you imagine a number line, we have 3.4 here, 3.5 here. This is giving us an answer, 3.4 is giving us an answer of 18.36, which is too small. This one's giving us an answer of 19.25. So if I try the middle one, which is 3.45, so I'm going to do that in my calculator. 3.45 squared plus 2 times by 3.45 equals SD, it's 18. So I've worked that out. That's 18.8025, which is too small. Okay, so this one here is too small. So that means my answer, my 19, is actually somewhere in this area here. So that means it is actually closer to 3.5. So what I had decided already was correct. But this 3.45 just proves that it is correct. I've got a couple of exam questions here for you to try. So again, pause the video, work through these yourself. This one is x squared plus x, and we're trying to get 62 this time. Now, a lot of exam questions are set up like this, where it'll say its solution is between 7 and 8. So they're already telling you which two numbers to put into your table first. So that is very helpful. So you can start with those two numbers and then go to your 1 decimal place. And you need to read your question carefully to make sure it is 1 decimal place, because some questions can ask you to go to 2 decimal places, which means you'll have to go a little further in and try and find out your answer to 2 decimal places. But this is a 1 decimal place question. Okay, so for this one, as I said, it already tells us to do 7, 8. So I'm going to put my 7 and my 8 into my table. So 7 squared plus 7. So 7 squared is 49, plus 7 is 56. So that is too small. So we'll try 8 now. So 8 squared plus 8. So 8 squared plus 8 is 72, which is too big. Right, so 62 is 10 away from 72. 56, it is 4, 5, 6 away from this. So we're slightly closer to the 7. So I'm maybe going to try 7.3. So 7.3 squared plus 7.3. Do that in my calculator. 7.3 squared plus 7.3. And that gives me an answer of 60.59. Which is too small because I'm trying to get 62. So if that's too small, I'm going to need to go up. So I'm going to try 7.4. So 7.4 squared plus 7.4 on the calculator then. 7.4 squared plus 7.4 equals, and that is 62.16. 62.16, which is too big. Okay, so my answer's going to either be 7.3 or 7.4. This here is 0.16 away, whereas this one here is more than 1 away. It's 1 point something away. So I know that 7.4 is closer, so I'm going to choose 7.4 as my answer. X is equal to 7.4 to 1 decimal place. Okay, our last, another exam question. No table first this time, so it's x cubed this time plus 3x equals 41. It does tell us to start with 3 and 4, so it has a solution between 3 and 4. Use trial improvement method to find the solution. Give your answer correct to 1 decimal place, and you must show all your working out. So the first thing we're going to do here is draw out our table. Okay. So our first column, remember, is value of x. Our second column is our equation, so value of x cubed plus 3 of x. And we're trying to get 41, so put our comment in here. So I'm going to put my 3 and 4 in, because they've already told me that. So 3 cubed plus 3 times by 3 equals. I'm going to write this one as well, and it'll work them both out. So 4 cubed plus 3 times by 4. Okay, using a calculator then. 3 cubed, which is 27, plus 3 times 3, which is 9. And that gives me 36, which we already knew was going to be too small. Okay, 4 cubed then, so we can use my calculator. 4 cubed plus 3 times 4 equals 76, which is too big. Now we can see that it is definitely closer to 3, because 41 and 36 are not that far apart, whereas 41 and 76 are. So I'm going to try 3.1 and see. 3.1 cubed plus 3 times by 3.1. I'll use my calculator for that. So 3.1 cubed plus 3 times by 3.1. And that is an answer of 39.091, which is too small. Getting closer though, so I'm just going to go to 3.2 now. 3.2 cubed plus 3 times by 3.2. Okay, so 3.2 cubed plus 3 times by 3.2 is 42.368. So 42.368, which is too big. That's over 41. Okay, so 39 and 41, that's a difference of 2. 42 and 42.368 and 41, that's a difference of 1.368. 3.6. I'm not quite sure. I think it's probably 3.2, but I'm going to do a middle value just to check. So 3.1 and 3.2. This one here is obviously too small, and this one is too big. So I'm going to check now 3.15, because that's the middle number, 3.15. So on my calculator, I'm going to do 3.15 cubed plus 3 times by 3.15 and press equals, and that comes out as 40.705875, which is too small. So this gives me something that is too small. So I know that it is between these two numbers here. So that means it must be closer to 3.2. So as I had thought, it is 3.2. So my answer is 3.2 to 1 decimal place. So it's a matter of trying a number and then improving that, trying to get a little bit closer every time to the answer you're looking whenever you're doing trial improvement. And these questions are normally worth quite a few marks, so it's really good to show you're working out, and you need a 3-column table to do that. Don't worry so much about the headings in each column, as long as you remember what you're supposed to put in each column. So the first column is your values of x. They're your guesses or your trials. And then the middle column is where you substitute those numbers into the equation that you're given in the question. And the last column, then you write in whether you're too big or too small. I hope you find this helpful.